Warm greetings from TNV Academy. Today in this session, we are going to discuss about supervisory control and data acquisition. However, before we start, let me tell you about the key takeaways of this session. At the end of this session, you will be able to understand what is supervisory control and data acquisition, which organizations use SCADA, components of SCADA, features of SCADA system, SCADA architecture, and the last one is benefits of SCADA. So let's start our discussion and understand what is SCADA. SCADA, supervisory control and data acquisition, is a category of software applications for controlling industrial processes, which is the gathering of data in real time for remote locations in order to control equipment and conditions. SCADA provides organizations with the tools needed to make and deploy data-driven decisions regarding their industrial processes. One of the most commonly used type of industrial control system, SCADA, can be used to manage almost any type of industrial process. SCADA system include hardware and software components. The hardware gathers, feeds data into field controller system, which forward the data to other system that process and present it to a human machine interface HMI in a timely manner. SCADA system also record and log all events for reporting process status and issues. SCADA applications warn when conditions become hazardous by sounding alarms. Supervisory control and data acquisition, SCADA, is a control system architecture comprising computers, network data, communications and graphical user interfaces for high-level supervision of machines and processes. It also covers sensors and other devices such as programmable logic controllers which interface with process plant or machinery. SCADA allows industrial organizations to control industrial processes locally or at remote locations, monitor, gather, and process real-time data, directly interact with devices such as sensors, valves, pumps, motors, and more through human-machine interface HMI software, record events into a log file. SCADA systems are crucial for industrial organizations since they help to maintain efficiency, process data for smarter decisions, and communicate system issues to help mitigate downtime. Now let us move forward and discuss which organizations use SCADA. SCADA system work well in many different types of enterprises because they can range from simple configurations to large, complex installations. SCADA systems are the backbone of many modern industries including energy, food and beverage, manufacturing, oil and gas, power, recycling, transportation, water and wastewater. Let us now discuss the various components of SCADA. SCADA systems include components deployed in the field to gather real-time data as well as related systems to enable data collection and enhance industrial automation. SCADA components include the following: sensors and actuators. A sensor is a feature of a device or system that detects input from industrial processes. An actuator is a feature of the device or system that controls the mechanism of the process. In simple terms, a sensor functions like a gauge or meter, which displays the status of a machine. An actuator acts like a switch, dial or control valve that can be used to control a device. Both sensor and actuators are controlled and monitored by SCADA field controllers. SCADA field controllers. These interface directly with sensors and actuators. There are two categories of field and controllers. The first one is remote telemetry units, also called remote terminal units (RTU). interface with sensors to collect telemetry data and forward it to a primary system for further action. The second one is programmable logic controllers (PLC) interface with actuators to control industrial processes, usually based on current telemetry collected by RTU and the standard set for the processes. SCADA supervisory computers. These control all SCADA processes and are used to gather data from field devices and to send commands to those devices to control industrial processes. HMI software. This provides a system that consolidates and presents data from SCADA field devices and enables operators to understand and, if needed, modify the status of SCADA controlled processes. Communication infrastructure. This enables SCADA supervisory system to communicate with field devices and field controllers. This infrastructure enables SCADA system to collect data from field devices and to control those devices. Let us now discuss the features of SCADA system. Although SCADA systems may include special features for specific industries or applications, most systems support the following features. Data acquisition is the foundation of SCADA system. Sensors collect data and deliver it to field controllers, which in turn feed data to the SCADA computer. Remote control is achieved through the control of field actuators based on the data acquired from field sensors. Network data communication enables all SCADA functions. Data collected from sensors must be transmitted to SCADA field controllers, which in turn communicate with the SCADA supervisory computers. Remote control commands are transmitted back to actuators from the SCADA supervisory computers. Data presentation is achieved through HMI, which represent current and historical data to the operators running the SCADA system. Real-time and historical data are both important parts of the SCADA system, as they enable users to track current performance against historical trends. Alarms alert SCADA operators to potentially significant conditions in the system. Alerts can be configured to notify operators when processes are blocked, when systems are failing, or when other aspects of SCADA processes need to be stopped, started, or adjusted. Reporting on SCADA system operations can include reports on system status, process performance, and reports customized to specific users. We will now discuss about the SCADA architecture. SCADA systems operate at 5 of the 6 levels defined in the Purdue Enterprise Interference Architecture for Enterprise Integration. Level 0. The field level includes field devices such as sensors used to forward data relating to field processes and actuators used to control processes. Level 1. The direct control level includes local controllers such as PLCs and RTUs that interferes directly with field devices, including accepting data inputs from sensors and sending commands to field devices actuators. Level 2. The plant supervisory level includes local supervisory systems that aggregate data from level controllers and issue commands for those controllers to carry out. Level 3. The production control level includes system-wide supervisory systems that aggregate data from level 2 systems to produce ongoing reporting to the production schedule level, as well as other site or region-wide functions like alerts and reporting. Level 4. The production scheduling level includes business systems used to manage ongoing processes. And finally, let us now discuss the benefits of SCADA systems. The benefits of updating legacy SCADA system include the following. Scalability. Modern SCADA systems are more scalable than legacy systems for several reasons, including better availability of supported hardware and software and use of cloud computing to meet workload demand. Interoperability. Legacy SCADA systems rely on proprietary hardware and software, resulting in vendor lock-in. Communications. Modern SCADA systems support widely supported and modern communication protocols which enable greater accessibility to SCADA data and controls. Support. Legacy SCADA systems may have limited options for support, while modern systems are more likely to be well supported by vendors. Use of commercial off-the-shelf hardware. Open networking standards and modern software development platforms makes third-party support more accessible as well. So, we have now come to the conclusion of this session. For your questions and queries on today's topic, we would suggest you to please put them in the comment section of the video and we will be really happy answering them. Till we meet next, it's best wishes from TNV Academy. Thank you.